Hello, young scientists. Today we're talking about matter. What is matter? Matter is everything around us. Your books, your toys, even you are made of matter. Matter has mass. Mass means how much stuff is in something. A big rock has more mass than a small pebble. Matter also takes up space. Can you think of things around you that are matter? Everything you see, touch, and even smell is made of matter. Now let's dive into the exciting states of matter. The first state of matter we'll explore is solid. Solids are firm and hold their shape. Think of an apple. You can hold it in your hand and it stays the same shape. A table is also solid. It doesn't change shape easily. Solids are everywhere. Your pencil, your shoes, and your house are all examples of solids. They have a fixed shape and take up a certain amount of space. Next up, we have liquids. Liquids are different from solids. They flow and take the shape of their container. Imagine pouring juice into a glass. The juice takes the shape of the glass, but if you pour it into a bowl, it takes the shape of the bowl. Water is another great example of a liquid. It flows from the tap and can fill up different containers. Can you think of more liquids? Last but not least, we have gases. Gases are invisible, but they're all around us. We breathe air, which is a mixture of gases. Think about blowing up a balloon. You fill it with air, which is a gas. The gas takes the shape of the balloon and makes it bigger. Another example is steam. When water boils, it turns into steam, which is water in its gaseous state. Gases don't have a fixed shape or size, they spread out to fill their container. Media group. Section 5. Melting from solid to liquid. Media group. Now that we know about the states of matter, let's see how they can change. Matter can exist in different states such as solid, liquid, and gas. Each state has unique properties and behaves differently under various conditions. One of the most fascinating changes is when a solid turns into a liquid, a process known as melting. Media group. Imagine you have an ice cube. It's solid and cold. The molecules in the ice cube are tightly packed together, giving it a definite shape and volume. This is what makes it a solid. Media group. But what happens when you leave it out on a sunny day? The sun's heat starts to affect the ice cube. The energy from the sun causes the molecules in the ice to vibrate faster and move apart. Media group. The ice cube starts to melt. As the temperature rises, the ice absorbs heat energy, causing the molecules to break free from their fixed positions. This transition from a solid to a liquid is a gradual process. Media group. Melting is when a solid changes into a liquid. This process occurs at a specific temperature called the melting point. For water, the melting point is 0 degrees Celsius or 32 degrees Fahrenheit. Media group. The heat from the sun gives the ice cube enough energy to change its state from solid to liquid water. This energy is known as latent heat, which is required to overcome the forces holding the molecules together in a solid state. Media group. Melting is a fun process. It's not just limited to ice. You can observe melting in many everyday items. Watching the transformation can be both educational and entertaining. Media group. You can see it happening with chocolate, which melts when it gets warm. The smooth, creamy texture of melted chocolate is a favorite for many desserts and treats. Media group butter, which melts when heated in a pan, making it perfect for cooking and baking, and even ice cream. On a hot day, ice cream quickly turns from a solid to a delicious, creamy liquid. These examples show how melting is a common and important process in our daily lives. Understanding melting helps us grasp the broader concept of phase changes in matter. These changes are essential in various scientific and industrial applications. For instance, in metallurgy, the melting of metals is crucial for creating alloys and manufacturing products. Scientists study melting to develop new materials and improve existing ones. By understanding how different substances melt, they can create materials with specific properties for use in technology, medicine, and more. On a molecular level, melting involves the transition of molecules from a structured, orderly arrangement to a more fluid and disordered state. This change is driven by the addition of energy, which allows the molecules to move more freely. Another everyday example of melting is a candle. When you light a candle, the heat from the flame melts the wax near the wick. The liquid wax is then drawn up the wick and vaporized to keep the flame burning. In nature, melting plays a vital role in the water cycle. Snow and ice melt to form rivers and lakes, providing essential water resources for ecosystems and human use. This natural process is crucial for maintaining the balance of our environment. So next time you see something melting, take a moment to appreciate the science behind it. Whether it's ice, chocolate, or a candle, Melting is a fascinating process that connects us to the fundamental principles of matter and energy. Section 6. Freezing, from liquid to solid. Just like solids can turn into liquids, liquids can turn back into solids. This process is called freezing. Think about putting a tray of water in the freezer. The cold temperature of the freezer makes the water lose energy. As the water molecules slow down, they arrange themselves into a fixed position, forming ice. Freezing is the opposite of melting. It's how we make ice cream and popsicles. Section 7. Evaporation, from liquid to gas. Have you ever wondered what happens to a puddle of water after it rains? You might have noticed that it slowly disappears over time, especially on a sunny day. This fascinating process is called evaporation. Have you ever noticed a puddle of water drying up after the rain? This is because of evaporation. Evaporation is a natural process where a liquid changes into a gas. It happens all around us, every day, in ways we might not even realize. This is because of evaporation. When the sun heats the water in the puddle, the water molecules gain energy and start moving faster. Some of them move so fast that they escape into the air as water vapor, which is a gas. This is the essence of evaporation. Evaporation is when a liquid changes into a gas. This process is not just limited to puddles. For example, when you boil water, you can see steam rising from the pot. That steam is water vapor created through the process of evaporation. The heat from the stove provides energy to the water molecules, causing them to move faster and eventually turn into gas. When the sun heats the water in the puddle, the water molecules gain energy and start moving faster. This energy comes from the sun's rays, which warm up the surface of the water. As the molecules move faster, they begin to break free from the liquid state and transition into a gaseous state. Some of them move so fast that they escape into the air as water vapor, which is a gas. This transformation from liquid to gas is a crucial part of the water cycle, which helps to regulate our climate and distribute water around the planet. Evaporation is also how wet clothes dry on a clothesline. When you hang your clothes out to dry, the water in the fabric absorbs heat from the sun and the surrounding air. This heat gives the water molecules enough energy to escape into the air as vapor. The water in the clothes evaporates into the air. This is why, after some time, your clothes become dry. Evaporation is a simple yet powerful process that plays a vital role in our daily lives, from drying clothes to forming clouds in the sky. Understanding evaporation helps us appreciate the intricate balance of nature and the continuous movement of water in our environment. Section 8. Condensation, from gas to liquid. Today, we are going to explore one of the fascinating processes in the water cycle, known as condensation. This is a crucial concept in understanding how water behaves in different states and how it transitions from one state to another. The last change of state we'll learn about is condensation. Condensation is a process that we encounter in our daily lives, often without even realizing it. It's the reason why your bathroom mirror fogs up after a hot shower, or why you see dew on the grass in the early morning. Condensation is the opposite of evaporation. While evaporation involves a liquid turning into a gas, condensation is the process where a gas turns back into a liquid. This transformation is essential in the water cycle, helping to form clouds and eventually precipitation. It's when a gas changes into a liquid. This happens when the gas or water vapor cools down. When the temperature drops, the water vapor loses energy and transitions into liquid form. This is a fundamental principle in meteorology and helps explain weather patterns. Imagine a cold glass of water on a hot day. You might notice that the outside of the glass becomes wet. This is because the warm air around the glass cools down when it comes into contact with the cold surface of the glass. You'll notice water droplets forming on the outside of the glass. That's condensation. The water vapor in the air loses energy and changes back into liquid water droplets. This is a simple yet powerful demonstration of how condensation works. The warm air around the glass cools down when it touches the cold surface. This cooling causes the water vapor in the air to lose energy. As the vapor loses energy, it transitions from a gaseous state to a liquid state, forming tiny droplets of water on the surface of the glass. As the air cools, the water vapor in the air loses energy and changes back into liquid water droplets. This process is not only important in our daily lives but also plays a critical role in nature. For instance, condensation is responsible for the formation of clouds, which are essential for bringing rain to different parts of the world. Without condensation, our planet's water cycle would be incomplete, and life as we know it would be drastically different. Section 9. Conclusion. Congratulations, young scientists. You've learned about matter and its three states: solid, liquid, and gas. You also learned how matter can change from one state to another through melting, freezing, evaporation, and condensation. Matter is all around us and it's constantly changing. So keep exploring and asking questions about the amazing world of matter. Remember, science is everywhere, and learning about it is always an adventure. Keep those brains bubbling, and I'll see you next time.